Hi, everyone. Thanks so much for joining us today. I think we're going to continue letting people in off the wait or out of the waiting room. People are getting their cameras set up and everything. But as everyone continues to do that, I'll just go ahead and get us started. Thanks for joining us today. This is Intro to Passive House Trades with Ken Levison from the Passive House Network. And then I'm Chloe Swick. I'm from the Tri-County Regional Energy Network. And before I pass things off to Ken, I have a few opening slides to go over, and then we have actually a special guest appearance from Enrico from EMU Passive, and he's here to talk more about our upcoming passive design build bootcamp. Okay. Thank you. We are recording this presentation, and you will receive a copy of the recording as well as the slides from today's presentation in an email in the next few days. We'll have a Zoom poll we're launching towards the end of today's training. It only takes a couple of minutes to complete, and it really does help us out a ton if you guys can fill it out. So please fill it out. And you can also feel free to add your questions to the chat or unmute yourself if anything comes up during the presentation. We'll be taking questions throughout. And then a little bit more about who we are. We're the Tri-County Regional Energy Network, aka 3C REN. And 3C REN is funded by ratepayer dollars that we all pay into in our utility bill through the public goods charge. And the benefit of being ratepayer funded is that there is no cost to those we serve for any of our trainings or events or programs. And as a regional energy network, we're able to return these dollars back to our local economy, which has historically missed out on a lot of these funds. 3C REN currently offers 6 programs focused around 3 service areas. These include training, incentives, and technical support. Today's training falls under the building performance training category. And to learn more about our programs and see events we have coming up, you can visit our website, 3c-ren.org. And then I'll pass it on to Enrico to tell us more about our upcoming bootcamp.
Thank you, Chloe, and hi, everyone. I'm the CEO of EMU Passive. We provide hands-on passive house training across the US, and we are coming to Ventura this year to do a boot camp in collaboration with 3C REN. So this is what you're looking at today. The dates are September 29th through October 3rd, and we have a couple of formats that I want to share with you because that allows a little bit of better understanding. Typical audience includes builders, general contractors, architects, designers, construction professionals, anyone working on buildings and building envelopes from the design to the construction stage. And we focus on the integration between design and construction, as well as we focus a lot on practical examples and the hands-on component, as we're going to see in just a second. As far as registration, at the QR code that you can see here, or if you go to emupassive.com or the 3C REN website, you will find a link to submit your application. And as long as, once you apply, uh, we share the information with 3C REN, and if you are approved, then you don't need to do anything. You just need to show up on the dates of the workshop. We take care of that registration. If you don't qualify, we have some tickets available for non-territory related professionals. So that is also an option. Can you go to the next slide, please? We have 2 formats of the training. The simplest one to start off with is the focus, that is all in person. We start off with the first 2 days with the building science course. That is what you see on the left-hand side of this picture, where we do 2 days of in-person building science course. Then we have 2 days of passive pod workshop, that is the hands-on component to it. And the last day is the certification exam for passive house certification exam. So the focus is one of the 2 formats that we have available. It is all in person. It is 4.5 days, starting on Monday, September 8th, ending on Friday, October 3rd. And you can find more information on our website. Next slide, please. The alternative to that, for the same content that we cover, is the hybrid format of the Flex Bootcamp. Again, it's the same materials, but you sign up earlier, we send you over the textbook and we give you immediate access to the online training. So you do not need to come in on Monday, Tuesday. You just take that materials online on demand. You can do that over a weekend. You can do that a few hours at night, whatever. It's on demand. And then you come in Wednesday for the hands-on component, and it goes through Friday for the exam. So the commitment in this case for the in-person training is 2.5 days instead of 4.5. We do provide lunches. We do provide opportunities for engagement to try to also maximize you getting to know other people in the training. That is very important in my experience in passive house and in construction in general. So these are the two formats we offer. And I'm going to put my direct email in the chat in case you have any questions. Thank you.
Great. Thank you, Enrico. So I'll just take it over, Chloe. Great, great. Yeah, that's wonderful. I'm so glad to see that and see it coming to Ventura. Can't encourage it enough. And we not only you see builders taking it, but as Enrico had noted, many architects also take it. And I think it's a great compliment and to the Certified Passive House Designer course that we do at the Passive House Network. And it really helps build a robust team to deliver high quality passive house construction every time. So today is a little bit of an introduction to passive house trades, more than a little bit. And we'll see how that ties into perhaps some of the more detailed training and hands-on training that you could see from EMU going forward. So I'll kind of mention that and definitely tie it in as we go. Briefly, I know many of you, I think, are familiar with us and what we do, but briefly, the Passive House Network is a 501c3 nonprofit. We are really dedicated to capacity building, education, and connecting people. Those relationships that Enrico was mentioning, peer-to-peer knowledge sharing, so important. And we have a membership across the country. We have regional chapters across the country, very active, Passive House California, and I'll speak more about that in a second. We are affiliated with the Passive House Institute, and really the global community is kind of the special sauce of it. And I think, yeah, having people from around the world working together and bringing, not just across the US, is really helps lift everybody's game and bring all those different perspectives. Along with, our core mission around education and capacity building, and really it's kind of a mission of culture change, right, to the building industry, and what's the vocabulary, what are the expectations, and how are we doing that? Seeing how Passive House can make a difference, and starting a few years ago, particularly after the Marshall Fire in Colorado, seeing how the benefits of Passive House in resilience could come to the fore in instances of rebuilding and building back communities with greater resilience. And so one of the things we're doing is collecting resources around that of various sorts. I encourage you all to take a look at our page on climate disaster support. We actually have a committee as sort of an ongoing project. There are unfortunately growing frequency, so as we go forward with that, and related to that, as with this initiative, I wanted to make sure everybody was aware of the design competition we currently have running. It was in response to the Los Angeles fires at the start of this year. And the idea of the design competition, which the deadline is September 30th, is to develop really what we consider a groundbreaking catalog of high-performance homes that inspire people to do more resilient, better buildings and inform, hopefully, the rebuilding efforts in the aftermath of those fires. And these are a catalog, hopefully, that will become, a number of them become pre-approved plans, go into implementation, and not just in Los Angeles, but across the state, across the country. The awards will be given at a event at the AIA Los Angeles Center for Communities on the evening of November 4th. So an open invitation to everyone. I will be putting links or providing links to all of these things, either if I get my act together during this presentation or at the end, and certainly along with emails going out, so you can find it. So we're excited about this. The reaction's been really good. And if you have questions about it, happy to talk about that too going forward. I do want to give a brief plug to our Certified Passive House Designer training that pairs really well with the tradesperson training that Enrico provides. It is a hybrid online training, live online and in person, not in person, live online and on demand. It's all remote. Much of it is at your pace, timed with reviews along the way. The kickoff for the fall cohort is October 2nd, with the exam before the end of the year. We also partnered with 3C Ren, and there are generous incentives there around that. And if you're outside of the 3C Ren territory, there are any number of other incentives that may be appropriate for your situation. So you want to check those out. So today, we're going to look kind of across the spectrum of issues that builders and trades people working in Passive House face. We want to start off with a sort of touch with some basics of Passive House. I think a number of you have definitely had a fair amount of Passive House education already. We will be brief on that, but we want to give it context, in the context of the criteria. And then we'll dive into some more of the particulars in terms of the team and process overview, and the meat of it, the enclosures, and then the mechanical systems, QA/QC, and some resources to close it out. So there are learning credits available for this class, and we can set those up and make sure you get those at the end. If you don't mind putting into the comments just to get a sense, are you all in the tri-state? Tri-state is where I'm coming from, in New York, Connecticut, New Jersey, the Tri-County area. You know, what background are you coming from? Or I don't think you're all builders per se, although I could be wrong. And if you have any previous Passive House experience or knowledge, to what level, if you want to share that, it would help me immensely. Usually there is a fair range of folks in these courses. So I'm going to take that as kind of the standard, but if you do would like to share any information, I can certainly use that to our benefit. So getting started here. So I don't see anybody clicking in yet. Hopefully you will. As I mentioned, I'm actually in New York. I'm in Brooklyn, New York. And just a quick note on my introduction to Passive House was a retrofit. It wasn't a new construction of a townhouse in Brooklyn Heights. And I was the architect on the project. I practiced architecture for a couple of decades. And when I first heard about Passive House, I was very lucky to have clients who were willing to take the plunge. And It's actually quite an old townhouse. It was pre-Civil War, 1849, I believe, was the original construction. And we did this gut renovation and really just transformed the performance, and setting it up for the next 100 years. I'll refer back to this perhaps a little bit along the way. One of the striking things is, and what the owners love about it and loved about it is the comfort, thermal comfort, the quietness, the resilience that's built into it. And the savings along the way, that year after year, you're just banking that savings from the energy reduction. And what was surprising and took everybody a little bit of a leap of faith in going in, perhaps, not really a leap of faith, but on these first projects, perhaps, all the other neighbors that had similar sized houses, as you see here, and this is you don't see the very top attic floor, but this is a 5-story house. It's not a small house. And the neighbors all had 12, 15 tons of air conditioning installed with them. We installed 3 tons of air conditioning. So a real true 75% reduction in the mechanical systems and making it more compact. And it was something that the system of Passive House and the methodology really needed to deliver to be comfortable to do that. And it was happy to report it all planned out very well and executed. We learned a lot along the way. And from there, kind of this has been the course of my work since. So briefly, and some basic, oh, thank you, Shaina and George. Good to see you, George. Dennis, great, thank you. Edward. Wonderful. Great, just taking a quick look to look at those. Great. So I like this quote from Wolfgang Feist, and I think it speaks a lot to where the industry is in general and what we're grappling with in construction, up and down. So Wolfgang Feist, who's the founder of the Passive House Institute, said, "I was working as a physicist. I read that the construction industry had experimented with adding insulation to new buildings and that energy consumption had failed to reduce. This offended me. It was counter to the basic laws of physics. I knew that they must be doing something wrong, so I made it my mission to find out what and to establish what was needed to do it right." And we see this a lot, and it's very frustrating as an architect, as a builder, as an owner. You're investing in these buildings, you've got good quality materials, they're going into the building, but you're not necessarily getting the performance out of them. And because somewhere along the line, the dots aren't getting connected. And I like to use the metaphor or the analogy of cooking. And particularly, I think this book lays it out very clearly, salt, fat, acid, heat, where you have these basic elements of cooking. And if you master these elements, you can make great meals again and again and again. And it's not accidental, and it's you have a mastery of it to a certain degree. And buildings are like that. There are things that drive performance, and Passive House, the gift of Passive House is really drilling into that. So we know Passive House is a building standard, a building energy standard. It applies to new and existing buildings. It's really the most rigorous efficiency standard available today. It's a performance-based approach. It's not just a checklist of items. We are going for specific targets of performance. And as we mentioned, it's focusing on mastering the drivers of that performance. It's important to notice not just houses, right? We can be factories, apartment buildings. There's a office skyscraper in Boston, high schools. There's a firehouse in Vancouver, all sorts. Passive house really starts with occupants, and it's this passive house is dealing with basic building science, but what's cool about it is that it just doesn't stop and start with the building science in and of itself. It's that the building science is driving the comfort and health, and the comfort and health is driving that performance, that greater energy efficiency. So main goals: thermal comfort of the occupant, hygienic conditions, healthy conditions for the occupant. Of course, the energy efficiency, durability, affordability, the idea of kind of future-proofing the building, right? This resilience going forward. So you could, on a cold winter day, sit by a window and be comfortable. And so this idea of efficiency and better living are supporting each other. They're not in opposition. And we see in the construction and in the quality of construction how this can be revealed. And really you're the driver of that in execution. There are so many benefits around passive house that you can really have different conversations with it. And it's been interesting to see, meet people where they are, what they're concerned about. It's been interesting to see the fire resilience really come to the fore over the last few years. Of course, it was there before, but in terms of grappling since the Marshall Fire in particular, and going forward, this idea that, we're not going to build a fireproof building, but basic strategies of passive house and principles of passive house can help support greater fire resilience. And so we have on that support page different resources and highlighting that. So it is part of a larger effort. Obviously, the landscaping is important. The materials that we're using is important. And we're looking forward to, in the competition, many examples of bringing these elements together. So as you are likely know already, these drivers, these fundamental elements can be boiled down to essentially 5 aspects. And 4 of them are all about the enclosure, right? This is really an enclosure first thing. We want to build a container that is optimized. And then the 5th principle is about the ventilation, the mechanical ventilation, and making sure that we're maintaining good indoor air quality. Yeah, thank you, Enrico. It's great you could come. And Nancy, yes, we will be sending the recording, and you'll get a copy of a PDF of the slide deck. So you don't have to worry too much about taking notes here. So we have continuous climate-specific insulation levels. It's a parka, for the climate. Depending on if you've got a harsher climate, you need a heavier parka. And we want that parka to be thermal bridge free at the connection. So where the floor is meeting the wall or the wall is meeting the roof or structures coming through, we want to minimize the interruption and the quality and the disruption to the quality of that thermal insulation. The air tightness is going to be continuous as well. And we want an airtight enclosure. And, it's really interesting to see in the conversations too, the air tightness really coming to the fore. That, we've often talked about keeping pollution out and being able to control the air inside, have filtered fresh air, maintain good air quality. With the greater immediacy and urgency of rebuilding after, forest fires every year where buildings are lost and new construction is being built in fire-prone areas, we see air tightness as being fundamental to keeping that wildfire smoke out. So where you had homes that may have survived the fire, but were essentially destroyed by smoke infiltration. Passive house air tightness can really mitigate that to a great degree. We have examples from the Marshall Fire. I know Passive House, where neighbors' houses that had also survived were essentially destroyed by the smoke infiltration. The Passive House owner was able to move back into their home, and with minimal, not even disruption or repairs. It was it was as close to a nothing burger as one might think possible. So these four things: the insulation, the thermal bridge free, the air tightness. I got to the fourth. The high performance windows and doors are continuations of that insulation and that air tightness, and it's letting in some solar heat gains. It's bringing in daylight. It's giving us views, and we can open the windows. We can have fresh ventilation, fresh air ventilation when it's appropriate and it's useful. But when we can't, we can lock it down. I think Mike Horgan at Cairn Collaborative out there in San Luis Obispo has a great analogy, comparing it to a car. When you're driving in a car and it's a nice day, you roll down the windows, you let the breeze blow through. But if it's polluted outside or it's really hot or cold, you want that car windows to be shut tight. You want to be able to have your environment in the car. You don't want the rain to come in either. And the Passive House is similar to that. So with those four, we have the heat recovery ventilation, ensuring that we maintain the highest quality of indoor air. This is all going into our energy model. The predictability of the performance is the critical thing. This allows us to dial in and optimize. It allows for design optimization and cost optimization, all of it, and really have control of the project. Right. So we see the performance being much tighter. So in terms of energy use, there's fluctuation. There's going to be differences between buildings, between use groups, people, individuals. But this is predictable. This allows us to really lower the sizing of the mechanical equipment. LEED does a lot of great things, but it's not necessarily giving us that tight bandwidth of performance, and code can be all over the place. So with the enclosure and the 5 principles with the ventilation, kind of setting the building up for success, the heating and cooling systems can be dramatically reduced, like that house in Brooklyn Heights, not my house, client's house, where we see a 75% reduction in mechanical systems and pull those systems back to the interior. And with that energy use reduction, we can go net zero, and with a reasonable sized solar array. So here's a passive house, a certified passive house in Los Angeles, with a solar array tucked onto the roof on the top there and operating at net zero. So let's shift gears. Any questions on this kind of basic passive house philosophy or approach? We'll keep going here. The idea is that construction is complicated. This is showing a big urban construction site, whether it's that, which is super complicated, or a single family home. There's a big process. There's a lot of different players in it. There are a lot of different components, and things need to come together to deliver. And the passive house focus, again, we want to see it as a gift, that it's really filtering and getting us to engage on a few things that really drive the performance and give us the results. of health, of comfort, of energy efficiency, durability, affordability, future-proofness, all of that. And so, you know, the trick is, while Passive House is definitely affecting things across the trades, probably the biggest is going to be the carpentry, right? This is the enclosure, certainly for single-family homes. Each of these areas has a role to play in how it comes together. An electrician or a plumber who doesn't understand the connections between decisions and actions on the job site and the final performance could ultimately really mess things up a fair bit and set things back. So each should have a general understanding of Passive House that are going to be working on these jobs, and specific knowledge of their work's impact. So the construction crews do not need to be masters of Passive House. You definitely want some builders there who have been through the CPHT training. It's not often where you get whole crews that have been through that training, but some people who can then teach other people and can guide and bring that understanding to the job site and really connect the work that they're doing to the final results. And we've seen again and again on job sites where, particularly when you get to the blower door, that the construction workers, whatever the level of competency, it could be the owner of the construction firm, the project manager, it could be a laborer on the job site, seeing the reality of an airtight enclosure, where those leaks are, what are driving those leaks, which could be a myriad of reasons, and making that connection is kind of a real aha moment, and we can talk through that. So you know, again, going back to this idea that there are definitely certain skills that are involved, but it's almost as important to have that idea of a culture shift, that the way you're talking about things and engaging things raises the work of everybody. It doesn't mean everybody's going to be like rock stars or anything, or know everything, but you have that kind of investment where you see, oh, if we figure this out and do this a little better, it's going to have this real world impact at the end of the day. So to reiterate this, perhaps, that, you know, the logic here is that in so many ways, like Wolfgang Feist identified with the insulation back in Germany back in the day, that the building industry can often be disconnected from what the drivers of building performance are, and that we're connecting those dots. And in the simple act of connecting those dots, we can really transform what the team expects to be able to produce and the capacity to actually deliver it. And the thing that we see jazzed about, you know, architects jazzed about, as well as engineers and builders, owners, is the empowerment that with these few clicks, they're like, oh, okay. And now we're going to be able to produce. It's not going to cost any more to do something this way versus that way necessarily, but we're going to really wring out a much higher level of performance. And I think it's important to note that it's not an exclusive thing, that everybody can do it. I like my other favorite movie is Ratatouille, where the mouse, or the rat, I should say, could cook, is a great chef, right? And Chef Gusteau is like, everybody can cook and everybody can build a passive house. It's really a matter of intentionally engaging things. And that can be a high ask sometimes, given all the pressures, but we see it happening regularly. I want to also, as we get in here, to note the resources that are available out there, and that you don't need to reinvent the wheel. There is a building database on the PHI website. Again, all these links will be there for you, where you can look at buildings and the systems that they used and the details, and you can find out what the teams were and who were working on them. There's certified components in the database, which helps. You don't have to use a certified component. And then we have on our website now a index of different companies that supply either certified components or Passive House compatible components. They don't not necessarily to be certified. So across the different areas that are critical to Passive House. So, years ago, when you were looking for windows, there was just a handful of suppliers, and you had to know who they were, and or you were completely lost. Today, there are over 30 suppliers and growing. There are lots of options, and we just put them out there. This is not, nobody's paying to be listed here. We're vetting it and just making sure that these are serious players across the scheme of things. So a great resource there. There are things like a couple of great books for wood framing. This Understanding Passive House is a British book. So some of it is going to, look a little bit different, but it's very applicable. And we see these details going in again and again in one form or another in projects across the US. This is an American book, Passive House Details, a great variety of things. And other books and resources here, depending on what your need is. And some of this stretches into commercial for sure. There are general building science resources. These are some of our favorites. There's a whole series on different climates from Building Science Corporation. I would say, interestingly, different manufacturers have sets of details that they supply, put out there as examples. And, all of these manufacturers have competitors, and you can easily substitute one way or another materials and components. There's a lot of options now, but the details that the manufacturers are providing can be very valuable and very much help you figure things out more quickly. Again, we don't need to reinvent the wheel. The Passive House criteria, I want to say a few words on that. Again, very at the risk of being overly repetitive, we're going for occupant health, thermal comfort, energy efficiency, durable, affordable, future proofing, that resilience. And it helps to remind us, like kind of like a mantra, and maintaining that focus when there's so much going on a job site and in the building design and all the decisions that need to be made. And it gets very specific with Passive House, right? The thermal comfort, we do not want to have interior surface temperatures that are more than 7.6 degrees Fahrenheit below the operative indoor temperature. I would say, you don't want them to have that variation below or above. You don't want the above is much more unlikely, perhaps. And the floors, we don't want them to get too cold. We want to eliminate the stratification of the air. We want this to be relatively calm thermally. We want to get rid of the asymmetry of the thermal conditions. That drives discomfort, it drives convective currents, it drives the need for more mechanical systems. It really drills down, and one of the things that you're doing as a designer, as a builder, is looking at every joint of that thermal enclosure. So you've identified the boundary of the thermal enclosure. And what are all those intersections? Passive House has a way of looking at those intersections, if there's a question about them, through a therm or Flixo model, looking at the thermal bridging and making sure that the weakest points, are strong enough that we're not going to get condensation, we're not going to get mold, we're not going to get damages. And so really focused on maintaining those even surface temperatures. The air tightness is critical, of course, and we have the 0.6 ACH50, which seems kind of absurd compared to, the 3 ACH50 or 5 ACH50 that we may see out there in typical construction. But it's not only possible, but we see it happening all the time. And we see crews who have done these projects a couple of times be able to do twice as tight, again, get down to 0.3 ACH50 or 0.2. And this is a huge driver of comfort and the overall performance, the efficiency of the building. The windows and doors, as we mentioned, we want those temperatures to be close. It's, again, 7.6 degrees. We're looking at the amount of frame per the glazing. A smaller window that has more frame is lower performing than a bigger window with less frame, given the glass is the same. So we like to see fewer windows that are bigger than lots of little windows. It's less frame, it's more performance, and you're getting the best values out of it. They can tend to be beefy. We see the triple glazing as being helpful not only in terms of thermal comfort, but in terms of protection, right? In terms of fire protection, that you have essentially sacrificial layers before the fire actually could breach the enclosure through the window. And then finally, criteria drilling in here to these core elements is the ventilation. And so we want good heat recovery, because this ventilation is going to be running 24/7 typically at a relatively low volume. But so we're going to have heat recovery of that air of over 75%. We're going to have an efficient fan. We're going to have a balanced flow. So that exhaust pulling out of the building is going to be within 10% of the supply air. We don't want to pressurize or depressurize the building typically, unless there's a use specific thing. We want to keep the smoke out. We want to keep the indoor pollutants down, so students and workers and family members are more alert and in control. So again, it's all about the enclosure and it's about the ventilation. Of course, we need heating and cooling, and we need domestic hot water and the other systems, and they're important, but they're not in that, really tight cone of the priority of the drivers of the performance. Because now you've defined the performance of the building with the enclosure and the ventilation, and now you need to close the loop with what was left, because you will need heating and cooling and make it efficient. So there's no hard specific things to do with it, but we want it to be efficient. And so a range of systems are possible. And successful approaches is keeping it simple. Don't overcomplicate things. We've built an efficient enclosure, and we should simply heat it and cool it. With the heat pumps, we're heating and cooling together, and we want to minimize refrigerant lines. Kind of similar with the domestic hot water, it's going towards heat pumps, but it's not required to be heat pumps. We want to minimize the circulation. We want the pumps to be efficient. And we want the electrical lighting and the appliances to be efficient. The bottom line here is kind of this idea of do no harm, right? You've built a fantastic enclosure, and the architecture is driving the performance. We don't want the heating and cooling and other systems to muck that up. It should deliver well. There are a few numbers involved. It's not so important. These are, you know, a heating demand, a cooling demand, air tightness, overall electric use. There's new construction requirements. There's also retrofit requirements. And these fixed targets really dial it in. You're very fortunate that in the 3C Wren neighborhood, those of all of you there, it's not that hard. If you're in Minnesota or, you know, somewhere in much harsher climate, you know, you have to flex those muscles a bit more. We're talking, you know, perhaps 2x6 wall with some continuous insulation around the outside of it. When are ducted HVAC and ERV overcomplicated? And what is it appropriate? Well, I would say you do. George is asking about the mechanical systems complications, and we'll come around to them more specifically. But you know, people can get lost a little bit in the controls and try to wring out like the last drops of efficiency with, you know, by making things a bit more complicated and control wise and zoning wise and in how you're doing it. The passive house, and if we're talking about single family homes, it's really an exercise in simplification. So it may, you know, one system versus another may get a little bit more complicated, but you're always pushing towards simplification. And you want to make sure that you strike the right balance. We'll come back around to that. Over 30 certifiers working in the US. Enrico is a certifier as well as doing the training and consulting. Certifiers are great because they're looking at a lot of projects and dealing with a lot of issues. There's a lot of institutional knowledge that you can take advantage of. We mentioned the components, we mentioned the training, we mentioned the criteria and goals. So let's dive in with this. You know, in a construction project, you know, you often will have an architect and some engineers, other consultants. A passive house consultant is certainly new. It could be a design build where you don't, you know, for a lot of projects, you may not have an architect, but we're going to have a passive house consultant. And that consultant could be within the architect's office. That consultant could be outside. It could be a standalone individual who just works on a bunch of projects as a passive house consultant. You know, it's conceivable that the passive house consultant is working within the construction firm. You know, if you have a design build firm and they're consulting on their own projects, that is completely legitimate. Of course, we have the builder and the trades, and it could be those various combinations. The verification, you know, we're going to have inspections. We'll talk about those to make sure that the components that were specified were actually installed, to make sure that details were actually executed per the design, per the energy model. And we're going to photograph those, right, and have that documentation. The ventilation is critical in terms of commissioning to make sure the air is getting to where it needs to be and that we have those flows that's closing that loop for the healthy indoor environment. And to set that up, we have the blower door testing. Typically, the verifiers are going to be independent of the contractors. and should be, frankly. There may be special cases where the contractor is able to do it and the certifier, understanding what the situation is, might accept it. But that's something you want to clear up front. What we have, and hopefully you have a certifier involved with your passive house project. You know, projects don't need to be certified, but I would say the certification is also like the great training and great experience, and really holds your feet to the fire in terms of, you know, how easy it can be to make a shortcut. A little thing here, a little thing there, doesn't matter so much, but you may not understand or really appreciate the implication of certain changes along the way. And maybe we'll try to point some out as we go through. But unless you've like traced that back into the PHPP or understood from other projects what the implications can be, it can really damage the performance of the building at the end of the day, and just not reach the level that is expected, that the client is paying for. They're paying for a passive house. They want you to hit the numbers. So this isn't that different from a typical job. You've got a new consultant, passive house consultant, who may be a component of one of the others, and you have the certifier, and you have a real focus on, well, I guess the blower door test is new too. It's kind of incredible that with the air tightness being so fundamental to wildfire resilience, that California is like not pushing it harder in the regulations and everything. We'll get there. We'll get there. What's so important when you're stepping up to build these things is the common language, the goal of passive house, and the willingness to kind of like learn from each other and work together. To have enough training, again, it could be wildly different in terms of the training. It could be, with some of the trades, it could be hyper specific. For example, if somebody's doing nothing but installing a window, they need to know how to do those window installations really well. And they don't necessarily need to know all the other nitty-gritty parts of it, but understand the connection of that to the final outcome. And a willingness to work as a team and to connect the dots. So let's keep going. The maintenance and operations, like the Living Building Challenge standard. So certainly maintenance and operations is important. And, you know, for any basic competency, and the commissioning in particular is of particular importance. So we'll talk about that. But this, you know, this is about setting up the building to go on its life. It doesn't, it's not saying it's not important. It's just not the focus of passive house. It's the passive house is about having that design and the energy model and the components that can deliver this predicted performance, and then it's up to the owners to carry that forward. You know, it's like teaching a child to walk and then setting it out on its way. Still a lot for that child to do to become a successful, have a successful life, but it's not necessarily the same person's goal or job to look over that child the whole time as they grow up. I just thought of that analogy. I think that works well enough. So the certification process overview. So the construction process, which is not unlike typical construction process, a few things I want to highlight here and are highlighted, is so important to do an initial check at the beginning when we're in early design. What are the programmatic assumptions? What are the criteria that we're going after? You know, and getting with the certifier ideally and understanding like how things need to be plugged in and lined up to make certification smooth, and that quality control along the way click along. You know, the worst thing, and then early as possible in the design phase, we're having the energy model completed, and we're putting in assumptions where we need to, where we don't have everything fixed, and we're refining that. Now, this may be happening within a design build context, and that's okay. What will be critical is this dotted line representing going from the design to the construction. And for the purposes of this and certification, construction is represented by the completion, and what do we need to show with the completed construction to get certification. Before we build, it's a really good idea to have a certifier review everything and issue a design stage assurance letter saying that if this project is built the way the plans are indicated, according to the specifications and what we see in this energy model, that is the optimization of all of that, you should have passive house performance and a certifiable building. And having this going in is great, because then the builder knows if I do X, Y, and Z, I'm going to get there. There's no questions. The toughest thing is going from design into construction, taking on the responsibility of building it when all the decisions haven't been made. And you know, construction, not every decision that is necessarily going to have been made, but they need to have conservative placeholders in place for things that may still need to be fleshed out, where they need to have, you know, taken care of all the things that really could impact the final result, and really have it be minimal. So as you're working through the construction, and we'll come around to this, you know, you have as-builts for the energy model, the photo documentation. So the as-builts for the energy model, along with the plans and the drawings and the specifications, the documentation of what actually went into the building, and that the model is still testing out. Okay, you have photo documentation, the blower door test, the ventilation system, and the executed builder assurance certificate. So in its boiled down form, it's not a sprawling set of requirements. There's obviously a lot embedded into these things that needs to happen, but it's not a crazy list of items, and they're all very focused, again, on those goals we've been talking about. So let's get into the nitty-gritty. So we talk first about the enclosure and the first 4 principles. Any other questions out there before we dive into this? I know we're just kind of crossing the threshold into actual construction. I'll keep an eye out. What I was going to say, any type of construction can be a passive house. This is a good news. So, you know, if you like working with wood frame construction, that's no problem. If for some reason your thing is masonry and CMU and brick and all of that, great. You can do a passive house. You can do it out of steel. You can do it out of straw. Really anything, anything that we want. It's agnostic in terms of the construction type. Now, you may have a range of sustainability goals. And again, this is another thing that differentiates Passive House. Passive House is focused on that performance of driving health, occupant health and comfort and resilience and so forth. And it's focusing on a handful of metrics to get there. But you may want to use low embodied carbon materials, and or source things from a certain place, or have any number of agendas, you can bring those to it. It's not exclusionary in that way. It's not going to mandate that for a Passive House certification. So it's agnostic. We have metal constructions that can totally work with Passive House, and there are implications to all of these, and we'll talk more of them as we go. Wood, frame, concrete. A lot of things that we see in common are this idea of continuous insulation, right? So this may be the wall for 90% of the Passive House buildings in the 3-county region, where you've got a simple wood stud framed wall with insulation in it and sheathing and continuous insulation. And the thickness of this continuous insulation is going to be, what do you need to make up that difference to make the energy model work? And we've got a back vented rain screen on the outside, air tightness on the inside. We'll go into all of this in more detail in a second. But this is like a very typical type of construction. And then the variations on it. You're not going to see this in your area, but up north in harsh climates, a lot of double stud. And we can do it out of metal. A great shortcut to diving into Passive House assemblies and enclosures and seeing how other people have done it. Again, not reinventing the wheel. So those books I mentioned at the beginning and some of the manufacturer guides, great things. But there's a whole bunch of companies that supply certified or certifiable enclosure systems. And then they're going to be adjusted to the climates. And this is on our website. You can go a bunch of different companies located across the country. And you can see the details and see how they're bringing the parts together. Great resource. Again, this is a level of insulation that you are not going to need or see, excuse me, in your area, but totally useful. So we'll work through some of this. The climate-specific insulation, like the assembly type, the insulation type can be any type as well. Here we see mineral wool insulation, continuous. It's the idea that we want to make a thermos is the most important thing. And so mineral wool, we have foam insulation, we have wood fiber insulation here. Again, the thickness is relatively thin here. This is actually multi-layered. It's pretty thick, ultimately built up. Pretty thick piece of wood fiber insulation there. Dense packed cellulose is a favorite of Passive House professionals. Certainly not a requirement, but it does have great hygroscopic properties, not hydrophobic, hygroscopic properties in moving. It's moisture resilient. It can move moisture around, hold moisture, release it. And here you have a similar buildup, right? Where you've got the interior finish and a surface cavity, interior membrane, insulation, sheathing, continuous insulation, and then the siding on the outside. Spraying of various kinds is certainly possible. Batt insulation is possible. It's not, batt insulation is not as preferred because it stops and starts. It's not actually continuous. And it can be a bit trickier to install and have that high quality. How many times have we seen it's either like there are gaps or it's stuffed too tight? The amount of attention that needs to happen with this, and it's pretty well established, the different grades of installing that insulation. So we often see it installed, but the continuous insulation on the outside is going to be doing is the workhorse of it. Or we like to see blown in cellulose. Rigid insulation is one of these things that can be great, but it's all about the continuity. And if it's installed in a way where there are gaps and they're not getting closed up, you're going to have the performance being undermined. So, and involved in terms of inspections and execution, there's going to be a greater level of care here to be done. So a lot of these things, in terms of what assembly system you're picking, the insulation you're picking, it may be a matter of just what you're comfortable with. And that's okay. If you can deliver to high quality with a certain system or materials, go for it. But as you're developing and as you're growing with your passive house knowledge and capabilities, we're always trying to think, how do we simplify this further? How do we ensure the chances of success, greater chances of success in doing that going forward? Problems with spray foam. So spray foam you can do, and it can be a fine insulation. What we've seen over the years is that there can be installation problems, and it can be a nightmare when they do happen, because it is a chemical. You're basically doing chemical manufacturing on a job site. For thermal value, the spray foam can be much more reliable. We're really hesitant to think about spray foam in terms of an air tightness methodology. It can often be sold for that, but if you were to put in spray foam, we would definitely want to see an independent air barrier that is going to be more robust in case there were issues at the end of the day. That said, there are projects that have just depended on spray foam and have worked and work well. So again, there's no hard rules, but it's you want to load the dice in your favor, so to speak. As you're thinking about putting the project together, it always goes back to the basic building science, right? And so the Building Science Corporation we like a lot, and they have a lot of great resources there. And the fundamentals all apply to Passive House, and Passive House is really about kind of uplifting those fundamentals. So we've got the bulk water we need to shed, like a raincoat. We have the vapor control to prevent wetting and allow drying. It's one of the big things. Not so tough necessarily in your area, but in harsher climates, in cold, harsher climates, working to prevent the wetting, talking about vapor retarders and whatnot. And then if it does get wet, to make sure that it's going to dry out is of primary importance. That vapor control is really what's going to allow the enclosure to dry. Air control and then thermal control. And again, we have this layering. So we have the structure, we have that continuous insulation. It's not even acknowledging insulation in the structure. It's all outboard. And we have the air tightness and water control with a back vented rain screen. That air control is going to be continuous. That's the red pencil or red pen. You can't pick it up. You've got to move through those details and figure out. And there can be a sequencing issue there. We like to have the air tightness layer inboard of most of the insulation, if not all the insulation, the majority of the insulation. We like to keep the conditioned air in the conditioned space. There is a lot of projects, and there are great projects that use the exterior sheathing as the air barrier or at the exterior sheathing. And you have the conditioned air then coming into that, that insulation. In a colder climate, in a harsher climate, you could have serious condensation problems there. And so there's a lot more of a dance here in terms of vapor control and condensation preventing than what you have in your neck of the woods. What I would say, and then I think we'll come around to this, you know, we want to, as a rule, no matter what climate you're in, we want to avoid vapor barriers. And it's very common for people to refer to the vapor barrier. So there's no sin or great fault in that. But it's confusing as heck because we really don't want them. We want an air barrier, and we could have multiple air barriers if it seemed like the right thing to do. We may have some vapor retarders, but no vapor barriers, because that is really limiting the drawing. We'll have a vapor barrier under the slab to the ground. We want to keep that hydrostatic pressure down, or out. And may at the actual roofing have, you know, that roofing membrane be a vapor barrier as well. But at the wall constructions, and at ceilings, typically no. We want to allow the drying. This is a little bit much in this slide, but talking about these goals of shedding water, vapor control, air control, thermal control. Again, this is kind of a, if not a wholly standard buildup, is something similar. So you've got the stud wall construction with the insulation between the studs, and then you could have sheathing on it or not, and you have the waterproof air tightness layer outboard, continuous insulation, back vented rain screen. Inboard of that framing, we have the interior air barrier, and this would be the primary air barrier, and the service cavity. And the service cavity is probably one of the bigger lifts culturally, I would say, that Passive House is trying to achieve, and you know, winning some battles where people are brought over to make sure that this service cavity is installed so that our outlets and the wiring and so much of the damage that happens at the surface of the interior and poking through is not disturbing that primary air barrier, that the air barrier is protected for the long term. In buildings that don't have the service cavity, or where the interior finish is serving as the air barrier, it can really be damaged, and you can lose that air tightness and that performance. Brick, panels, siding, masonry, and so forth. Just various different types. SIPs we can do. Double stud walls, so this is in a harsher climate. But again, you see the same elements happening again and again. This is a variation on I-joist outrigger. So you can see here, these are I-joists that are turned vertically, and they're being used as the ribs to hold the siding and the sheathing on the outside, and allowing for a deep cavity of insulation. So this is a really thick parka, and it's going into a much harsher climate. You don't have to worry about it. But a great methodology. A lot of projects have done that. We can use insulated concrete foam, has great continuity, can deliver air tightness as well. Insulation under the entire slab on grade. And this is typically, I mean, we could talk about like extreme hot climates and the advantages of not doing it completely under the entire slab, but that's kind of a special case. Typically, we want that insulation to surround the thermal enclosure completely. And that means getting it up around under the slab and up around the edges, and we're going to connect in to the wall insulation. And we'll come back around to that, I believe. Thermal bridge free construction. I'm going to speed this up a bit, I think. You know, it's not rocket science. There's as folks develop, in some of those books that I showed you have details where the thermal bridging values are worked out. A lot of common details are out there now that we know are thermal bridge free, and you can just look at details. Many times the certifier can look at the details and say, oh no, you're good there. But certainly many times it's not the case. And we'll talk about what pushes you one way or another here in a bit. But it doesn't need to be so complicated. Like here we have the cellar wall coming up and intersecting with the floor structure. And we have a thermal bridge. There's just too much heat loss coming through here. If we just change the material of this to a porous concrete, we have just enough thermal resistance that it's okay. It's a much better condition. Now, it's not necessarily obvious to see that, but this is one of the things in the planning stages that the consultant is going through and making sure is addressed. So we want to eliminate all the shortcuts, the thermal shortcuts. The thermal bridge could be a few different things. It's that change in thickness of the insulation layer where it's just gotten significantly different, and changing the characteristics of that. It could be a straight up penetration, right? Like a slab, balcony slab coming through. And this is where you have this real radiator effect where these buildings are just heating the outdoor environment. And also where we have changes of direction, the characteristics of this. There could be a negative thermal bridge, which is in this case, which is a good thing because we're double counting the insulation at this corner, or just a straight up thermal bridge. So you're looking at all these connections again and again. We're looking at thermal quality of the studs. A wood stud isn't that bad, but we don't want a lot of wood studs in its place. Metal studs, as we know, are much more conductive and can cut that insulation value in half of the wall. Structural elements we've got to be super conscientious about. Basically, that parka is kind of like the no-fly zone. You don't want stuff going through it. You want elements to stop and start. We'll look at some examples of that. So we're looking at all these pieces. We're looking at the weakest points. And the window frames are, the window connections are very common weakest point in how they are installed. So advanced framing is a nice, shorthand for a lot of just more efficient, energy efficient building in the assembly, and getting as much wood out of the assembly as possible. So more materially efficient, but much more thermally efficient as well. So no stud after stud after stud after stud. There better be some continuous insulation going on the outside of this construction to make up for that solid wood wall that's appeared. Much more to our liking is where the framing has been considered, and we'll come back to the window installs in a minute, And we have the alignment. The window is right in line with the insulation. Here we have the sill as well. This is this double stud wall, and you've got a gap between it. And we have a nice thermal break in that continuity. And you see the nice thermal lines there. They've even got insulation outboard of the frame. Again, that frame is the weakest point of the window. And to the extent that we can minimize that in the design and how we put it together, and the construction details and sequencing are so important with that. The attachments for the insulation, we don't want them to be undermining. So to really be conscious about what we're using there. The wall ties for the bricks, the clips, we're doing more of a clip on facade. Bricks, rather than having a continuous angle that it's support that's directly to the slab, we have intermittent supports so that insulation can be continuous. It's still going to have a point thermal bridge, but this point repeated is much better than having a linear thermal bridge of that steel. A great example is at a parapet where you have a typical example where you have the insulation continuous, which is great, but it stops here. And then you've got the continuous roof insulation stopping at the parapet. So now we've got a clear thermal pathway here. You could wrap it over the top that way, but kind of counterintuitively, the best way and the best kind of materially efficient way, more elegant way, is to use a block, a more porous masonry block there that has a slightly better R value. And that acts as a bridge and again, cuts it just enough to be acceptable. That's the AAC block, the autoclaved aerated concrete. And we're seeing it used more and more, particularly at parapets or other areas where masonry is needed or can be used to bridge between where you're oftentimes you're going from inside to outside insulation and other things. Balconies, we talked about those buildings that have radiators to the world. We can actually mitigate that with some fancy thermal breaks that has insulation, and these are bent stainless steel rods. It's still going to be a thermal bridge, but it's minimized. It's not nearly as bad. And maintains essentially what we're looking at, right, is, oh, what's the temperature going to be at the surface where she's sitting up against the wall? We want that to be warm enough to have thermal comfort. It also prevent condensation and moisture damages. There are lots of options now for structural thermal break material. And so again, where you have the line of the insulation, this steel support is coming through, we're actually going to stop it and start it. So it's all about how you get through that thermal enclosure. This is a fun detail where this is new construction. They framed the wall on the roof and they have their sheathing and moisture barrier. It's also an air barrier. Rather than having the tails coming out here, as they are here, they have created an independent eave that carries that through, but is attached to the furring below. So you have just a complete separation, and that insulation within the wall is not interrupted. Similar thing here, where they've got this roof structure below it, and then they've got what will be a back-vented roof, a cold roof, what we call, where sheathing is going to go over these furring strips and out on the eave like that. So kind of interesting. Really important when you're looking at bringing together these different elements of the enclosure, that you're not undermining it with certain parts of the system. So we've got great continuous insulation here, but then it's got a metal stop, and that metal stop is going to pull the energy right around that insulation. Back to this example where we have the edge insulation coming up, and we're using it to contain the slab, and then this is now cutting into has continuity with the wall insulation. So again, 2x stud wall. We've got our service cavity inboard with air tightness layer, inboard sheathing, furring, and here they've done sheathing with shingles on top. Not sure, there are a lot of different combinations are possible with that. Thermal break material. So again, like at the walls where we have the steel coming through, this is a slightly different situation. We have thick insulation that's going to go on this roof. So we don't want the steel posts to go through the insulation and sit directly on the structure below. We're going to use structural foam blocks, plastic blocks, I should say, to hold those up to the height. 8 inches of insulation is going to connect to. So you have complete thermal separation there. All of these things is what leads to the predictability of that energy model and that assurance that you're getting the performance at the end of the day. Right, air tightness. All the benefits. So the air tightness is one of those things where you will have a test at the end of the project, and you need to hit the number, or you're not going to have it. You're not going to have the performance or the certification. So planning is going to be super important here. And the test is it's pressurizing as well as depressurizing. We want to see how the enclosure elements are reacting under negative and positive pressure, and then it's the average of the two that are taken as the final result. So you could have a number that's slightly above it and one slightly below it, and hit the actual test. People are really scared about this, and it's not something to take lightly, but we see really remarkable success rates. And we see it where, I mean, to the point where the teams know what they're doing, they're going to hit it. A lot of times in initial projects, we definitely want to see teams doing preliminary blower door tests, or just have the contractor run a fan. You know, you've got some good industrial fans, put a fan in the door and or a window opening with some plywood and tape it up and just have it run. On one project, on that project in Brooklyn Heights, we would just have a fan running with negative pressure and at different times. And so you could go around and feel and figure out where the leakages were still existing, where things weren't connected properly. And, you know, it wasn't going to be measured as if a final test, but the tighter the better. If you can feel airflow through where the air barrier should be, you have a hole, you close it up, and you just make it tighter and tighter and tighter. You can't be too tight. That's you know, we like to see it as tight as possible. So a big part of this is, like, you will have ideally some people really responsible for the air barrier. You know, you have the carpenters typically who are installing it. and connecting it to its various parts and pieces. But you want to make sure that the electricians and the plumbers and the mechanical installers know about it and recognize it and report if there are any cuts made to the barrier. And this kind of cooperation is what's really important. Or if they just see damage that was done to the air barrier, because it's really a whole system, right? There are lots of parts and pieces. It could be sheathing, it could be hard things, it could be softer things like membranes, it could be caulking, it could be tape, could be sprayed on. And how those things are going to come together is really critical. So we have lots of different methods of doing it. Again, if there's a way that there's a preference and a familiarity, chances are that's probably the way to go, at least initially, until you figure out, like, ultimately what project delivery is going to look like. And oftentimes from project to project, for any number of reasons, it's going to change. So we have air barrier membranes. These are all interior, and you can see the service cavity here, and then exterior membranes with the strips for the back vented rain screen going on. So kind of variations on a theme. It could be sheathing. So zip sheathing is often used as well, you know. And the one thing we just want to make sure, again, in your climate is so forgiving, typically, that a lot of the belts and suspenders and the conservatism of the approach of some of the building science doesn't need to be as rigorous. I hate to have anybody relax too much, but it's a lot more forgiving. It could be plaster, could be concrete, where the under slab plastic is coming up the wall and is going to be taped and connected to the concrete there, and is going to act as part of that air barrier. I think the biggest thing to emphasize here, or one of the biggest things, is that the air barrier is essential to the functioning performance of the building, the thermal control, the efficiency, keeping good indoor air quality, and keeping all of that wildfire smoke out. You don't want it to be a sacrificial layer, what we call a sacrificial layer. So historically, sheetrock was considered and was a methodology for providing air tightness. And among other issues, which works to a certain extent, but among other issues in terms of really high performance and durability, is just that it gets beaten up, it gets cut, it gets poked, it cracks, it moves. We want our air tightness barrier to move with the building, to have some forgiveness. We want materials that can stretch and move a little bit. There are question marks. OSB. We've seen OSB used successfully as air barrier, and you just tape the seams. And we've seen OSB fail. And it's not exactly clear why. I think it's partly just due to the thickness of the OSB. It wasn't thick enough, or the density and how it was made. But we've seen that. We've seen failures where you're relying on an inherently porous set of materials assembly for air tightness. And you can see they've taped the membranes on there to spot the leaks. We've seen it also with spray foam. Minimize the penetrations, right? If the air tightness is sacrosanct and we want to protect it, we want to have as few penetrations through it as possible. You could have outlets within the membrane, and so membranes coming around these, and you're taping these, outlets into it. But so much better to not have the hundreds of penetrations that come with that need to be very well installed and then maintained. Here with the service cavity, no penetration, you can leave it, set it, and walk away. So at the ceilings as well. Flexibility, things move. So here's like a rubber gasket for pipes. It's also possible with wires. Unfortunately, the traditional kind of like foaming the bits and pieces, it's going to crack over time. It's going to lose its tightness. We want it to be connected for the long term. Flexible connections, having a little bit of slack, having a material that can move and give with it. Be very cautious about using super rigid materials and use the directions. All right, windows, doors, it's extension of the insulation and the air tightness. We want this thermal quietness with the passive house window. One of the things that people really notice when they go into a passive house, it's like, not only is it acoustically quiet, which all these things help bring it, but it's thermally quiet. We've talked about this. Fewer, bigger windows. It's more of a design thing, but as a, if there's design build or there are choices to be made, and as builders can contribute to the conversation, by all means. The quality of these windows, very good. So on the certification, just to note, in the component database, you get a lot of information with a certified window, and you get all the values straight into the energy model. Super helpful. Much harder with a non-certified window, but not impossible. Here's another, great look at this jam where we've got insulation on the outside going up just as far as they can cover that frame. So now the distance between the insulation and the glass is absolutely minimized to this gap, which is great. It's much better performing. We're not going to ever have double hung windows in a passive house, a traditional double hung window. There are super special double hung windows from Austria that could actually work, but they're not in a whole lot of projects. What we're going to typically see are tilt and turn windows. You can use casement windows, anything that can lock positively. The passive house window is going to have triple locks and is going to, have that kind of feel, that air tightness, that you're going to close it. But maybe not the right analogy exactly, because but it's like, you close a car door of a Mercedes versus, Toyota or something, and you feel that difference of the door closing. It's not unlike that with the windows. We talked about the comfort and hygiene. The placement of the window is super important, and to be cognizant of this. If it's asymmetric to the insulation, and this is very common in typical construction where the window is way outboard and whatever that construction is behind it, it is. I mean, this is obviously much thicker, but you don't have great alignment with the insulation here. This, we have much better alignment, and we have better performance with it. And then again, in the other direction, we saw this detail before. This is another no-no, right? Where the insulation is separated from the window, and we have a clear thermal bridge traveling here. Much better, and this is a very common passive house detail, is where, especially if you have a masonry construction, is to pull the window outside of the masonry. You don't put it actually in the masonry pocket, but you pull it to the face of it on a ledge, and that way it's now set within the insulation and you have that continuity. So details like this detail alone, and then how we're tying the air tightness between the window and the construction changes everything in terms of the overall performance. And so it's things like this that you're going to be working through with the Passive House consultant, and with the certifier and others on the team to make sure you've got an optimized detail. And it's a great thing. We see builders all the time. This is a retrofit situation. So they don't have to make the windows smaller because they're not putting this bigger frame within the same opening. They're pulling the frame, proud of that. And they're going to put insulation over the existing facade to come up to the frame. But what we see are builders bringing their experience, their knowledge in how to put things together and bringing solutions to say, okay, this may work and get the Passive House results, but if we did it this way, this other way, we can get the same performance and it's going to be easier and cheaper. Or it's just going to be less of a hassle, and consequently, we're going to have a better result. How the window connects to the construction can happen in a whole bunch of different ways. Here, they're actually wrapping the window frame with tape, and then they're going to lift it up into place and then tape to the surrounding membrane around it. It could also be a combination of tape and liquid. We see where the clips are here. That's a flexible liquid membrane that is applied to just make sure that there's no way air is going to get in and around that in any respect. No metal sill pans. So it's fabric sill pans of one sort or another. You may be doing a test of a window, sometimes typically, not in smaller residential, although you may want to test just an installation and make sure you've got it airtight. Again, many manufacturers. So let's take this. We've done this. This is different types. So with that, let's go on to the mechanicals. The ventilation is where we'll spend most of our time here, and then we'll be winding it down. Well, there's a few other things. I'm going to speed through this. So all the reasons for good ventilation, very specific design criteria that we want to hit. Of course, certified units are preferred for their predictability. And for residential, it's almost plug and play. We can do decentralized and centralized systems. They could be interior or exterior units. There's a lot of flexibility. So here's a big exterior unit that would be up on the roof or in a basement or next to the building. This is what we typically see in a residential unit. So you've got this, the heat recovery, the energy recovery ventilator here. You've got these big gray pipes going to the outside. So one's supplying and one's exhausting. And then you have the distribution. So one is supplying the fresh air and it's going to a manifold. And then these are all basically home runs, these spaghetti ducts. And then you have the returns, the exhausts, the extracts, and coming back into the manifold and back into the unit. So you need to make room for this. It is one of those things, like another appliance that didn't exist before, and it needs to be accessible, and you don't want it to be buried somewhere in the construction. It's like classic, a lot of passive houses is just common sense. one thing that maybe isn't common sense, but it's obvious enough once you're told it, is that the critical thing with these ERVs, we want them close to the exterior, because they're outside essentially. Once that air goes through the heat exchange, you know, this is outside air. These ducts are outside, and they need to be insulated well and have good vapor barrier on it to protect from moisture damages inside. So you can see these are the ducts going to the outside. They're insulated. Once the air has gone through the heat recovery, these on the interior side, they don't need to be insulated. It's essentially darn close to room temperature at that point. So to the extent that we can limit the lengths of these ducts, we are minimizing any risks associated with having outdoor air inside. And you're also improving the energy performance. And so with this kind of spaghetti going through the house, probably the most critical, well, one of the critical aspects is just the planning of it, right? This is something that we're typically not used to. And you know, with some simple planning, it doesn't require a whole new approach to assemblies or building a house, but you do want to know that you're not going to have a header in the way or a beam in the way, and or some plumbing that's going to be in the way and prevent you from doing it efficiently. And this is going to make the final commissioning and balancing so much easier. For kitchens, you know, the typical passive house approach is going to be to have a recirculating hood with a charcoal filter, you know, that you can knock down the grease from the cooking itself. But the actual ventilation of the space is going to be the passive house system. And so you're going to have an extract location relatively not on top of the unit. It needs to be a distance away, but not far. And you know, when you need to purge, you open a window briefly for the amount of time to let the air clear. This is very typical. They can be more complicated, and if you can have a purely extract hood, oftentimes, you know, you're going to need to have makeup with that, and you may need to have conditioning of that makeup air. Not ideal. I'm not even going to go into this. Larger buildings and everything that's required with ventilation is a kind of another ball of wax. The thing that's nice about the residential units, and you've got it pre-planned, and typically with the help of the manufacturer, you've got the flow rates and the locations nailed down, pretty straightforward. If they execute and install correctly, the balancing should not be that difficult, but we want to make sure that we're getting the air to the rooms in the quantities and the extract in the quantities as designed. And we want that balancing between the supply and the exhaust at the unit, at the exterior, to be within 10%. And here we see 1% differential. And that's going to ensure the performance of the building and the energy use of it. Really, the heating and cooling is about right sizing the systems. You know, everything, I don't want to say everything is going to heat pumps, but everything is going to heat pumps, right? And we're getting our heating and our cooling. It's typically going to be an air-cooled heat pump. You could do ground source. The loads are so small that typically, and especially in your mild climate, there's really no reason, and this would be an example of overcomplicating. You know, you could do a ground source heat pump and other bells and whistles like that. But honestly, because you need cooling, you could, you know, do the air source heat pump. Very common today, very relatively simple. I think the commissioning is the critical thing. We've seen projects where they're built beautifully, and they're getting some crazy energy bills, and they realize that their mechanical equipment is acting wacky. And so this is really important about ongoing commissioning and ongoing maintenance, and how the building is operating in that way. You want to be conscious of that. I would say that, one of the big things that we've seen it from project to project where they've combined the ventilation and the cooling, and typically heating and cooling, because it's the same thing. The issue is that the cooling is typically running at much higher volumes than are needed for ventilation, and so you have what theoretically may work, kind of fundamental incompatibility that can be quite difficult to really balance the airflows properly. That there's more wear and tear on the equipment than need be. And we like to have just that spaghetti doing its ventilation thing, and then however you're tackling the heating and cooling, it's happening that way. So, that clear separation is super important. I'd say another thing in terms of the trades that, Passive House gets really uncompromising on is this idea of continuous insulation, like the building enclosure, for conditioned air or hot water pipes, conditioned and cold water pipes for that matter, because that domestic hot water system is basically a heater inside the house, right? And it's continually heating the space if it's not well insulated. And so over the lengths of the pipes, to make sure the carriers and attachments aren't interrupting the insulation. And the same for the ducts, for ventilation ductwork, it's not conditioned air, but where we have conditioned air, we want control of that. Domestic hot water, couple of quick things here. It's really about efficient layout and all the things. And I know there are a number of talks just about domestic hot water that 3C-REN has, and definitely recommend finding those because it is about just delivering the fundamentals of what we know to have an efficient hot water system. Again, minimizing those losses to the space so that the energy is used for the intended purpose. Oftentimes now it's heat pump hot water heaters, and of course, if they're unitized and they're inside, we want to make sure that they have enough space and that we're accounted for properly. The fact that it's going to be cooling the space, right, as it's heating the water, and accounting for that. They can be noisy as well. We want to make sure that that is taken into consideration. Split heat pumps are another great solution. I'm not even going to go into this. We talked about the insulation. More on the insulation. Too much, if that's possible. The pumps, to make sure they're going okay. So let's see. So back to QA/QC, the schedule. It's your typical construction schedule. You want to identify those passive house things in the construction. And the big thing is, as we spoke of early, make sure that unresolved items get resolved and closed out. To the extent that these open items stay open, can spell trouble for everybody involved. That the submittals are provided to the passive house consultant and are signed off. And if there's a question, that the certifier may want to see it, that they're in the energy model, that what you're installing is actually in the energy model, or they have a good conservative number in the energy model that will take care of what you're putting in. It can really hamper things. So that's like one more step in that submittal process to make sure that you have a passive house sign off on those submittals. That the representative photos, the photo documentation does not need to be extreme. It's not, you know, we're showing representative photos of what's been done. The duct leakage testing, this is for bigger buildings. The smaller residential buildings was just plug and play with the spaghetti ducts. The biggest problem that we've seen is if they've accidentally installed like the supply to the return grill and vice versa, and it's just, you know, there were some mistakes made in how you're connecting it, which hopefully will be found out before you close things up. So the basic elements you want in there. The verification plan can be really useful and important. And for bigger projects, it's absolutely essential. The city of Vancouver, actually, because they have incentives for passive house buildings to make sure that they are hitting the marks, they require a certain amount of verification planning. And to know who's responsible for what and when, specific to the things that we've been talking about, that the ventilation commissioning agent and the blower door tester are identified and are on board. Oftentimes for the smaller residential units that we're talking about, the manufacturer could be is quite often the commissioning agent. They'll come and set it up for you. It depends, but that's certainly a possibility. Yeah, and just going through all of that. You know, folks are going to be inspecting, and what are those things? And again, the insulation, the continuity, the air barrier, the continuity, the window performance values, and that equipment. The HVAC and domestic hot water equipment are very important at the end of the day for the ultimate functioning of the building and energy usage. It's not just, they're just yeah, not as much of the focus in going through it. These, we're not going to go through all of this right now, but I think, you know, a lot of things here, and I spoke to a little bit of this in the schedule, are, you know, pretty straightforward when you realize it. But at the end of the day, it's this idea that we haven't done the early groundwork so that the different workers on the job site appreciate the goal that we're going after and how their job can affect that final performance. That they have a role to play. Everybody on the job site has a really good role to play to implement the performance targets and then protect them and make sure they're not undone. And then you've got to redo work. And setting that up is really setting up success. There are a number of things for certification. I'm running out of time, but we'll go over a few of these things. Mock-ups can be great. It's usually bigger projects, not necessarily for a single family home. But if you can, they're always recommended. There are things we can do about helping build the right culture, and you can have an air boss that is like, you know, the strict person on the site going around and kicking everybody's butt who's not, you know, treating the air barrier correctly. The ventilation performance is critical. Photographs. There's a manager's declaration as well. You know, and we're making sure that the as-built really are the as-built and the final energy model. You know, to reiterate here, as we're going in with the project development and then certainly into construction, we want to meet early with the certifier. We want to identify the critical elements and develop a verification plan. We want to maintain a dedicated inspection log for those passive house items. So you've got the regular inspections that you're doing as part of the construction, but really handy to have something that segregates the passive house mission critical pieces, so that's clear. Organizing photos as you go. One of the biggest nightmares is, yeah, we took a picture of everything and they're all in this box and we don't really know what's what. And finally, empowering the team, which is all of this is part of. So it's about building a culture of quality. It's about, anybody being able to do it with a little bit of education, contributing to a lot of knowledge around it. The focus is the key. So that's it. I see a couple more questions, which I'll address quickly. And I know there's a quiz. This is the resources. So you'll get all these links, probably more than you're up for. And happy to follow up if you have questions and you want to ask or that come to you in the coming days and weeks. Feel free to reach out. My email is ken@passivehousenetwork.org. I'll drop it in the chat in a second. And welcome you to do it. So that's good. So let me just answer, if it's okay, Chloe, I'll answer these couple questions and then.
Absolutely, Ken.
Okay, great. So the least toxic and least brittle cracking option for sealing gaps in rigid insulation. I don't know off the top of my head, to be honest. I would say there are a number of, you need to, dig into material compatibility is a key thing, right? As these different things come together, it actually is not a bad idea once you're going to an air tightness system in a way is to use all the parts and pieces that a given manufacturer may provide so that they're all working well together. So presumably those rigid insulation manufacturers have recommendations for materials to use with them. And that would be the safe kind of bet for performance. And then the question of their toxicity, certainly, with that. How do we get Lexus luxury passive homes to market affordable Toyota prices ASAP, SoCal and Central? It's the question across the country and everywhere. How we do it is not the quick part is the tough thing. It's really we see the cost driver, the biggest cost driver being experience, and the teams that have internalized the methodologies and have teams that are not operating out of fear but operating out of the opportunity of making like great building, are able to bring it in very close to normal construction so that it's almost the cost part of it is never going to come out of the conversation or off the table totally, but it should be minimized. And with all the benefits that you're getting, it's like it makes so much more sense. Could a central HRV without ducts work? No. So the problem is there. So it's potentially possible to do central heating and cooling, like with heat pump air handler head, like centrally in the house, to do that. But even that I wouldn't recommend because doors are kept closed and there's not enough, like we're not moving air through the house like an HVAC system. It's the ventilation system air moves very slowly. The reason why the HRV without ducts doesn't work because we need to place the air in every room. So every bedroom gets an air outlet. And every occupied space. So the living room is going to have an air outlet and a certain amount of ventilation with it. You're either supplying that directly into the living room, or perhaps you've got bedrooms on one side of the living room, you're supplying for them, and you've got exhaust in the kitchen on the other side of the living room. And we have that kind of cascading ventilation strategy. So we know the ventilation is getting through, that the living room is being ventilated. But because we also need the bathrooms to have a certain amount of exhaust air that's running, those need to be ducted. And all those ducts have to go back to the unit so that we get the heat exchange and we have the control over the air. We only want those 2 holes through the enclosure. Those are the only 2 holes that you get, is the supply air and the exhaust air. Everything else is buttoned down. Great. I know we're a little bit over time here, but if there are any other questions, I'd be happy to answer. I'm going to say thank you. Oh, can you clarify the process for thermal bridge calculations and resources? Yeah. So essentially where you have those joints, so where the floor is meeting the wall or the roof and whatnot, and you have basically linear thermal bridges there, you're going to want to know that those are minimized. So you have the detail, and you can draw that detail in a program called Therm. It's a free program. It's a little clunky, but you can do a calculation on it that will give you the values. And you can put those values then you can then redesign the detail as needed to make it more thermally strong. And then you end up putting the values that you've calculated, the final detail that you're happy with, and you've got the value for that. You put that into the energy model, into the PHPP. And that's part of the overall calculation. It's one of the differences. So Therm is one that's free. There's another one, Flixo, that's more robust, that costs money. If professionals who are doing it regularly are typically using Flixo, but Therm is a great way to start. We have a class on demand on Therm on our website you could check out. But those calculations, and including those calculations in the energy model, is one thing that really separates Passive House from typical kind of energy efficient construction, because those values, those impacts of all those details and the energy flows can be quite large on a building. And if you don't know what they are, and if you don't try to minimize them and get control of them, it's one of these reasons to oversize a mechanical system, because the engineer doesn't believe that it's going to do as well, and likely shouldn't. Yeah. So hopefully that helps. Great. Good. Thank you.
Thanks, Ken, for that awesome presentation today. Just a few closing slides to leave you all with. 3CRN has a really great service called Code Coach. If you're ever dealing with any element of the energy code or the green building code and you need help or advice or a different set of eyes interpreting the code, our partners at Inbalance Green Consulting will be there to answer your call, answer your email, and they are super, super helpful. So I recommend taking advantage of this service if you haven't already. Go to the next slide, Ken. We have continuing education units available for this class. If you'd like to get those units and have any questions about that, you can email my coworker, Danica. Her email is on the slide here. We also have some exciting classes coming up. You've already heard about both the Passive House Designer Consultant Training, as well as the EMU Passive Boot Camp. Both of those are coming up this fall. So that's a really great opportunity to dive in a little bit deeper to the Passive House standards. We also have a few other webinars coming up in the next couple of weeks. Best practices for hot water distribution. We have an Ask the Experts event all about enclosures. This is an office hour style event. If you have any questions about constructing high performance enclosures, and our instructor for this is Judy Rachel, and she is really terrific. I recommend this event highly. And then we also have an Emu Passive event coming up. It's a panel discussion on high performance construction in California. So I think all these are going to be really exciting. And that's it for me. Thank you all so much for being here today, and I hope to see you guys all on more webinars in the future. And thanks to everyone who took our survey. It really does help us out a ton, so I appreciate that. All right, and with that, I think unless there's any more questions, well, I'm actually seeing one more question from Nancy, so you can go ahead and take that.
Okay. Yeah, as far as I know, in California, there has not been an allowance for insulation. We have seen it happen in several jurisdictions across the U.S. in New York and Washington State, but again, I would just emphasize you need so little insulation in your area that you shouldn't feel the impact when one would hope. I don't know if you're talking about a retrofit and adding the insulation and making maybe non-compliance worse or something. Definitely want to get with the building department up front and discuss that. I don't think there's anything in place to just allow it. Terrific. And final plug for Enrico and the Certified Passive House Tradesperson class. He'll take this and all these aspects of it and dive in, and the hands-on stuff is super special. Build some of the assemblies, deal with the air tightness issues in the flesh. A lot of fun.
Absolutely, that's going to be a lot of fun this September and October. All right, thanks everyone so much for joining us today. Thanks again, Ken, and I'll see you all again soon. Bye.
Thank you, Chloe. Thank you, everybody.